Hey guys, welcome to Pill Reaction, wherein we discuss about the drugs and its adverse reaction. In this lecture, let's focus on a fascinating repurposed drug that's chloroquine. Now, a quick review of the drug. Chloroquine belongs to the antimalarial class of agents. It was first introduced against all 5 species of Plasmodium and highly effective against the blood schizons. Not only as antimalarial, the drug is also now popularly repurposed in treating many diseases such as HIV, Q fever, fungal infection, Sturgeon syndrome, rheumatoid arthritis, sarcoidosis, lupus erythematosus, cancer, and even now against coronavirus. The popular brands around are Resolution, Nevaquine, Anaquine, Wellquine. So, coming to its mechanism of action. Firstly, by alkalization of vacuolar and lysosomal pH that inhibits protozoal food vacuole functioning, endocytosis, lysosomal fusion and function. Secondly, its immunomodulatory effects, which is used in treatment against autoimmune diseases such as rheumatoid arthritis. Now, in this lecture, let's focus on chloroquine's antiviral action on coronavirus, which was used as emergency use authorization drug. So, this coronavirus on here consisting of spike proteins or simply S proteins on its surface, which allows it to bind to ACE receptors, ACE2 particular receptors on the host cell, which is a great way for the virus to gain entry into the host cell, which is then endocytosed into a endosome, which fuses with lysosomes, where the virus breaks down at lysosomal acidic pH to give out the free viral RNA, which further helps in viral replication. The chloroquine has the ability to alkalize the lysosomal pH by inhibiting the proton pump on lysosome, preventing it being acidified, thus inhibits viral replication. And secondly, the interesting property of chloroquine, that is its zinc ionophoric property. So zinc alone can't enter into a cell, but with chloroquine it can actually attach to the drug and can be guided it through the plasma membrane. Now the question comes to your mind, why do we need the zinc, right? Zinc inhibits the RNA-dependent RNA polymerase enzyme required for viral RNA replication, thus blocks the multiplication of virus in the host cell. So lastly, we do have to know about the new antiviral mechanism of the drug. So it all has to do with the cell membrane around the ACE2 receptors. They're actually called sialic acid attached to the cell membrane, which is a small receptor existing near ACE2 receptors, which actually binds to the spike proteins of coronavirus that indeed aids in viral entry into the host cell. Chloroquine blocks these receptors too, thus inhibiting coronavirus entering the host cell. Here comes the next question to you. After having so efficient mechanism of action, but still why chloroquine or hydroxychloroquine was withdrawn from the treatment of COVID-19? The answer lies in the ADRs caused by chloroquine and hydroxychloroquine. Quinines are highly bitter, also a gastric irritant, causing nausea, vomiting, and epigastric pain. Secondly, they stimulate the pancreatic beta cells to release insulin, as a result causes increased risk of hypoglycemia and even may end up to coma. Thirdly, quinine produces neurotoxicity, particularly at high doses, resulting in convulsions. And lastly, the main thing, these drugs causes dose-dependent prolongation of QT interval. This happens as a result of blocking the rapidly activating delayed rectifier potassium channels. When we say QT interval prolongation, that simply means increased depolarization of cardiac muscles for longer duration of time, which happens due to excessive intracellular sodium and calcium levels. And even by blocking of outgoing potassium channels, which otherwise was responsible for hyperpolarization or simply relaxation of cardiac muscles. Chloroquine mainly acts on these delayed rectifier potassium channels and blocks them, leading to persistent depolarization, which increases the risk of arrhythmias. Hope you got all the answers why chloroquine was withdrawn from the treatment of COVID 19. Thank you for watching. If you think this video helped you gain knowledge, then please consider it sharing. Let's learn together. For more such pill reaction videos, subscribe to our channel and stay tuned for more.